Hiya, my name is Kar, and today I'm gonna go over proportion inference for Stats 1b. Proportion inference is a very annoying one, in my opinion, because it's the only type of inference, like only one that has a different standard error for the significance test versus the confidence interval, which is very frustrating. I am gonna try to explain it as slowly as possible, but this is mostly just try to memorize the difference. Maybe like try to find some basically tricks to remember when to use what. So, what is proportional inference? Well, proportional inference is basically instead of having our mean and our basically our mean and our standard deviation, we're going to look at proportions in a group. So that would be basically yes or no answers in a survey, for example. So if you have 30 people and 15 people said yes on a survey, that would mean that your x is 15 and your n is 20. Then your at 30, then your proportion would be 15 divided by 30 would be 0.5, and that is your proportion. There are a few building blocks that are going to be important within proportion statistics, proportion inference, but I'm going to go over each of them step by step. So yeah, let's get to it. So these are the building blocks that we're going to be using in our proportions. So we've got our null proportion. This is only going to be important for the one sample proportion significance test. We don't really use it for the confidence interval because we never do, and we're going to do some shenanigans for the two sample, but these are... So that's the null. That's, for example, generally in a group we expect 50% to be correct, blah, 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 blah. Depends on the group. We're going to go over it slowly. Then you have your sample proportion. That is our proportion, and we get that by basically taking the x and the n. So you use these two to get that by basically doing x divided by n. So that is the example that I just gave, where it's 15 divided by 30 would be 0.5. So our p hat would be 0.5. So with that, you can basically do everything when it comes to the one sample proportion inference. So let's go over the formulas in a second. And I'm going to explain how the significance test and the confidence interval are different this time. Okay, so I wrote down the formulas, and I also highlighted that we are using different p-values for everything. So you can see that in the standard, the significance test, that our standard error is calculated using the null proportion under the root, whilst in the confidence interval we use our sample proportion. This is a simple case of just memorizing. There is no real rhyme or reason to it, from what I at least I haven't found a way to really easily memorize this stuff, especially not when it comes to the one sample. But just keep in mind that under the root, we use different values depending on if it is a significance test, where we use the null, and if it is the p, the p hat, in the confidence interval. The way that I memorized it was basically, well, the significance test is the only one that uses the null. Thus, we use the null with the significance test. This doesn't work in the two sample, but I have another trick for that one when we go over that little piece of information. So we've got the sample, the sample formulas now, one sample formulas, and I'm gonna go over an example first, And then we're going to go over the two sample formulas and examples. And afterwards, I'm going to have both the one sample and this two sample next to each other so you guys can sort of see all of the different formulas together, and you guys can basically make a connection in your own heads to try to memorize how to tell the difference and that sort of thing. Alright, so I wrote down a little example. We see that we have surveyed 30 people, of which 17 have reported that they drank coffee in the morning. We assume that 50% of people did drink coffee, so that is going to be our null. And then we're going to do both a significance test and a confidence interval, and we're going to use alpha level of 0.05 and a confidence level of 95%. So let's first look at our building blocks. So we want to look at our null hypothesis. What is our null hypothesis? Well, that is literally just the assumption that we made. So we had a belief that 50% of people drink coffee in the morning, which is the same as 0.5 when it comes to proportion, because 100% is 1 and 0% is 0, so 50% is 0.5. Then we have 17 successes, because 17 people reported that they drank coffee in the morning. Then we have 30 people total, and with that we can calculate our p hat. So that is 17 divided by 30, which is 0.567. So let's first do our significance test. Let's start with how all significance tests start. So that is our null hypothesis, which is that the true proportion is 0.5 versus our alternative, which is our proportion is not 0.5. Always keep in mind, this is the first step of every significance test. Just have your hypotheses written out. Now let's actually get into the formula. So remember our formula, which was z is p hat minus p null divided by the square root of p null times 1 minus p null divided by n. So let's plug in those numbers. That is 0.567 minus 0.5 divided by square root of 0.5 times 1 minus 0.5 divided by 30. Well, we put that in a calculator and we get 0.734. Well, then we're going to look that up in our formula, which is right here. So we can see it's the 0.7 over here and the 0.3 over here. We'll look that up. That is, let's see, that is 0.763, let's see. Yes, 673. It is positive, so we have to do 1 minus 0.7673, which is 0.2327. Well, we're going to compare that to our alpha level. So alpha is smaller than our p-value over here. Thus, we fail to reject a null. So we're just going to accept that probably the true proportion of people that drink coffee is 50%. That is how we do our standard deviation. Now let's do our confidence interval because it's slightly different. So we still use the same building blocks, still keep those. So now let's first look at our formula, which was p hat plus minus z times the square root of p hat times 1 minus p hat divided by n. So instead of using our null, we use our p hat again. So let's plug in those numbers. That is 0.567 plus minus 95% confidence interval, and proportions, everything is z, so we can just use our z-score of 95%, which is 1.96 times the square root of 0.567 times 1 minus 0.567 divided by 30, which gives us a score of 0.177. Well, then we look at our interval plus 0.177, which gives us, let's see, 0.939 and 0.744. So our confidence interval would fall between 0.39 and 0.744. That's it. So that is everything for the one sample proportion inference. I highly suggest just doing this a bunch because I got really confused about it. So let's now look at our two sample formulas, and then I'm also going to do a example for that one. Alright, I wrote down the formulas and also the building blocks that make up the formulas, and I highlighted what is the difference between the significance test and the confidence interval. So as you can see, we use different things under the root between the two formulas. The way that I try to memorize it, I try to basically see this P, so this one, as our null hypothesis, or our P0, just like we did in our one sample. So if it is a two sample and I don't see a 1 or a 2 with it, I'm gonna assume it's always going to be for the significance test. And for the confidence interval, you basically just do the same thing, but you use the individual p hats instead of the overall p hat, which is x1 plus x2 divided by n1 plus n2. It is the overall proportion. This part is the same as every other two sample t procedure, where technically it is like this plus delta, but delta is 0, so we just ignore it. Yeah, this is a lot of just memorizing, I'm afraid. So let's just go over a example so I can kind of explain how to visualize it and how to use your building blocks to construct a proper proportion inference. Okay, I wrote down a little example. We surveyed two classes. Class 1, which had 25 people, declared that 14 of them preferred summer over winter. In class 2, with 30 people, 19 said that they preferred summer. We have a alpha level of 0.5 and a confidence level of 95%, because we're going to do both a significance test and a confidence interval with this example. So let's look at our building blocks, which is always the first step. Just write down all of the information that they gave you. Well, the first, most basic one is, in class 1, we had 25 people. So N1 is 25. In class 2, we have 30 people. So N2 is 30. Then in class 1, 14 of them said that they preferred summer. And in class 2, 19 of them said that they preferred summer. So now we have this. Now we can do everything over here. So let's first start with just the P1. So the P hat 1. So that is the proportion for class 1 is 14 divided by 25, which gives us 0.56. And let's do that again for our proportion for class 2. which is 19 divided by 30, which gives us 0.633. Then let's do our total proportion, which was had the formula x1 plus x2 divided by n1 plus n2. So that is now 19 plus 14 divided by the 25 plus 30, which gives us our p hat of, let's quickly check, 0.6. Perfect. Now let's first do our significance test. First step of a significance test is our null hypothesis. So what is our null hypothesis here? We think that there is no difference between class 1 and class 2. So we think that the true proportion between the two of them is going to be the same. So p hat 1 is p hat 2, that sort of thing. Versus our alternative, which is p hat 1 isn't p hat 2. So the overall, there's a difference between the two of them. Well, then let's look at our formula, which was our z, which was p hat 1 minus p hat 2 divided by the square root of p hat total times 1 minus p hat total divided by n1 plus p hat total 1 minus p hat total divided by n2. And if we plug in those numbers, would be 0.56 minus 0.633 divided by the square root of 0.6 times 1 minus 0.6 divided by 25 plus 0.6 times 1 minus 0.6 divided by 30, which would give us minus 0.550. Well, let's look that up in our formula, or in our sheet. So that is over here. Let's see. That is minus 5 over here. And minus 5 over here, which gives us 0.2912, which is 0.2912. This is bigger than our alpha level of 0.05. Therefore, we fail to reject. The null. So that's it. Keep in mind that we're using the total proportion instead of the individual proportions in this formula. So yeah, that is about it. So let's look at the confidence interval now. So let's do it again, but now with this confidence interval. So our formula for that one was p hat 1 minus p hat 2 plus slash minus z times square root of p hat 1 times 1 minus p hat 1 divided by n1 plus p hat 2 times 1 minus p hat 2 divided by n2. So this time we use these under the root. So let's plug in those numbers. So we have 0.56 minus 0.633 plus slash minus. We have a 95% confidence interval, so our z-score would be 1.96 times the square root of 0.56 times 1 minus 0.56 divided by 25 plus 0.633 times 1 minus 0.633 divided by 30. Let's move this one a little bit that way. Well, we plug those numbers in and we get a interval of 0.26. Then we're going to basically plug those in to our interval. Minus. There we go. So our interval will fall between 0.333 and 0.187. So that's our interval. That is the only difference between the two. This is a difficult one 100% because they switch it up in between the confidence level and the significance test. I try to keep in mind that the significance test always asks for P1 and P2 in the beginning. Therefore, under the root, we also use P1 and P2. And meanwhile, in the confidence, like the significance test, this would basically be a stand-in for the null, which we also use in the single sample proportion. But I will admit this is probably the more confusing part of Stats 1b because they kind of just change it up and don't really give a solid explanation. So I suggest just doing it a bunch and try to basically make mental hooks for yourself to memorize it more easily. But yeah, that is everything for proportion inference. I hope this helped.